Hi, and welcome to Solar for Strata data analysis. On this map, you can see a number of strata buildings in the Greater Sydney area have now taken up solar. 95% of these sites have solar connected to the common area meter. 4% have solar connected for individual lots, and 1% are using the innovative Illume Sol Share technology developed in Melbourne. If we look at the solar system sizes by building type, you can see as we move from townhouse into low rise, into medium rise, and into high rise, we have a gradual increase in the size of the solar systems that are being put on the roofs of these buildings. Now, if we look at the solar system sizes by lot size in the strata, for example, how many apartments there are in the apartment building complex, you can see there's also a growth in the average size of the solar system with the size of the number of lots in the building. For example, with apartment buildings with under 30 lots, the typical size of a solar system is 12 kilowatts, and this grows to 39 kilowatts with apartment buildings that are 60 lots and above. If we look at solar system sizes by building age, this gives us an insight into how more modern buildings are actually getting larger solar systems installed onto them than the older buildings, which could be more like the red brick or white brick walk-ups that were developed in the 60s and the 70s. Also, a number of new developments in Sydney now have solar systems installed at the time of construction, which also gives an indication as to why we're getting larger solar systems on the more modern buildings. If we look at the solar system sizes and we compare as-built versus retrofit solar systems, interestingly, the retrofit solar system sizes are a little bit larger at 25 kilowatts than the as-built solar systems at 23 kilowatts. Now, if you think about the person that's actually financing the solar systems in an as-built environment, it's usually the developer or potentially an embedded electrical network provider. And both of those parties don't have the same incentive to put as large a solar system on the roof as, for example, a strata committee that's arranging a retrofit of solar. If we go a little bit deeper, we can see that solar system sizes with and without embedded networks also have some differences. So the buildings that have embedded networks typically have a slightly smaller solar system than buildings that don't have embedded networks. And this, again, would come down to the likely financier of the solar system being the embedded network provider, and the embedded network provider not wanting to overcapitalize or future-proof the size of the solar system as much as perhaps a strata committee that's looking ahead to adding electric vehicle charging or electric heat pumps. Finally, we'll have a look at solar system costs in dollars per watt by building type. And the key driver of the cost here is the lifting cost to get the solar system to the roof of the building. So as we move into higher buildings, the cost of an elevated work platform, a scissor lift, or a crane actually becomes the item that adds the most additional cost into the overall cost per watt of installing a solar system by building type. So I hope you've enjoyed solar system data and strata apartment buildings. Thank you.